Okay, so here we're going to look at using the scalar product in vectors to find the size of an angle. So let's have a look at this question. A box in the shape of a cuboid is designed with circles of different sizes on each face. The diagram shows 3 of the circles, where the origin represents one of the corners of the cuboid. The centers of the circles are these 3 points. Find the size of angle ABC. So I should point out, whenever you're finding an angle, if they're using 3 letters to denote the angle, the middle letter is the angle you're finding. So we have ABC, so it will be this one here. So you would draw a line from A to B, a line from B to C, and that will be theta. There, that will be your angle. Now, one thing I do want to point out with the scalar product, the formula is cos theta is equal to u dot v over the magnitude of u times the magnitude of v, where u is your first vector and v is your second. So in this case, u would be the vector BA and v would be the vector BC. And so BA will be my first vector and BC will be my second vector. Now, strictly speaking, when we use this formula here, we have to be careful that both vectors are pointing away from the angle. The formula does still work if both are pointing in. It does not work if one is pointing in and one is pointing out. So in this case, it's preferable if they're both pointing out. It just keeps things simple. So step 1, we're going to find the vector BA, which will be a vector u, and the vector BC, which will be a vector v. So let's find BA. So BA is obviously A take away B. So it's always the second vector, subtract the first one, which will be, so A is 607. Be sure you write it as a vector. Subtract B, which is 056. Which will be 6, negative 5, 1. And we'll do exactly the same thing to find the vector BC. So BC, again, second one, take away the first one. C is, we can just see it there, 450. Subtract away B, which is 056, which gives us 4, 0, negative 6. Okay, now we have our 2 vectors, BA and BC. So I'm actually going to rewrite the formula using BA and BC in place of u and v. So cos, and instead of using theta, I'm actually going to use ABC. So I'm going to replace theta with ABC. And I'm just going to put an angle symbol above it. So that's going to be BA dot BC over the magnitude of BA times the magnitude of BC. So in case you don't know, these vertical lines mean magnitude, i.e. the length of the vector. How long is it? So let's find BA dot BC and the magnitude of BA and the magnitude of BC. So BA dot BC is going to be, and to find BA dot BC, you simply just do the first 2, so like the I terms, the I's multiplied together, plus the J's multiplied together, plus the K's multiplied together. Now, some people call them X, Y, and Z's. You can call them X, Y, and Z's if you want. Strictly speaking, we should keep X, Y, and Z reserved for coordinates. So for C, 4, 5, and 0 are the X, Y, and Z coordinates, but when we're talking about the vector C, 4, 5, and 0 are the I, jth, and kth components of the vector. So let's work this out. So that's going to be 24, take away 6, 18. And we're also going to find the magnitude of BA and the magnitude of BC. So magnitude of BA is going to be, it's just Pythagoras, it's just that squared plus that squared plus that squared. So 6 squared plus, what was it again, negative 5 squared plus 1 squared, which is 36 plus 25 plus 1. So 36 plus 26 is 52, I think, if my arithmetic is not off. Let me just double check this. So make sure it's turned on. Don't know if you can just make that out there. So I'm going to do 36 plus 26 in 62. Close enough. Okay, I'm going to do the exact same thing with BC. It's going to be 4 squared plus 0 squared plus negative 6 squared. And this time I'll double check what this one is. So 16 plus 36 is, oh, this one's 52. Interesting. Okay, so now we just sub these three things into the equation and work it out. So cos ABC is going to be BA dot BC, which was 18, over the magnitude of BA times the magnitude of BC. So that's root 62 times root 52. Like so. And then you can work that out if you want. I'm going to leave it as is and just take the cos over to the other side. When you take the cos over, be sure that you change it to cos inverse. So it'll be cos inverse of root 62 times root 52. I'm determined to write root 52 here. Okay, so ABC, plug that into the calculator. So we'll do, it's kind of hard to make it out there. So it'll be shift cos of, make sure the bracket's in, I can't really see that. There we go, I can just make it out now. So it'll be 18 on the top line over root 62 times root 52. Okay, not the easiest to make out, but, and we get 71.5 degrees. And that's it. Simple as that. So just to reiterate, use the formula, find your two vectors. Be careful that you find BA and BC in this situation. BA is pointing away from B and BC is pointing away from B. You would not find AB and BC, which a lot of people would want to do when they see this. If you find the vector AB, then AB is actually pointing in to B, not away from B. So you'd have to be careful you do BA, if that makes sense. Once you've found your two vectors, simply plug them into the equation. It's better if you work BA.BC separately on the side, likewise with the magnitude of BA and the magnitude of BC. That way, if there's an error somewhere here, you'll still get the majority of the marks. Plug everything in and just work it out. Hope that was helpful. Thanks very much.